Alright guys, this is solving systems with inverse matrices. You guys will probably be mad at me after you watch this video because you'll realize how easy solving with the calculator really is. First thing I want to just talk about is what an inverse matrix is. Well, if something's an inverse of something else, for example, if you guys remember the multiplicative identity for inverses, or we'd multiply 4 by 1/4 to get 1. Well, in this case, we're multiplying by the inverse matrix to get back to the identity matrix, which is 1s for each one. So I'm going to just show you what that looks like. I'm going to use whatever matrix I have in A, and when you multiply them, you just do A, and then the inverse key is actually the same key as the matrix button, A inverse times itself. I'm going to multiply it times A, and when you hit enter, now ignore this. This basically means 0. That's just a calculation error type thing. But 1.1 times 10 to the negative 12th means you're moving the decimal 12 to the left, which is basically 0. But here's the key. You get a matrix where you get 1, 1, 1. That's called an identity matrix. We can use this fact to solve these equations. Okay, so let's start working with those. So we call this the coefficient matrix. And this is what I require when you set these problems up. I want to see your 3 matrices and then the answers. This is called the variable matrix. And this one is called the matrix of the constants. So to solve, what happens is you basically do A inverse on both sides. And you have to multiply this side, the A inverse on the left side, because otherwise it won't work. Because when you multiply matrices, it has to have has to follow the rules of columns and rows. We won't get into that right now. But when you multiply this, this turns into basically 1. So you're left with x is equal to A inverse B. And that would be your answer. That's all you have to do for these problems. So let's look at this first one. My A matrix are my matrix of coefficients. So I have -3, 4, 2, -1. My variables are x and y. Again, this is A, this is x, equals my matrix of constants, which is 5 and -10. Okay, so to solve this, you have to use your calculator, and we're gonna, to solve it, x equals A inverse B. So I'm gonna plug into my calculator both A and B. So go to second inverse to get up the matrix menu, edit your matrix. My first one's gonna be a 2 by 2, and I have -3. Make sure everything's entered correctly too. 4, 2, and -1. Alright, enter. And then do second matrix again. Go over to edit. And we're going to edit B now. B is a 2 by 1. 2 rows by 1 column. And we get 5 and -10. And this is how easy it is. You hit enter. And now we just do the operation of A inverse B. So you do second matrix again. We want to use A first, so hit enter. Hit the inverse key, which is right above the square key. Now go back into the matrix menu, second inverse. Go down to B. And when you hit enter, you will get your answer. It'll be in the column of, it'll say XY. So if you hit enter, I get the matrix -7, -4. What that means is that XY is equal to -7, -4, which tells you your answers. So my answer for this problem is -7, -4. And that's how you solve a system using inverse matrices. That's it. Yeah, start getting upset now at how easy it is. Alright, let's do 2 more. If you want to try them first, pause the video. Pause the video. Again, I need to see this on the test just to see your setup. You can't just give me an answer. I need to see the work. Alright, so my A matrix for this one, if everything's in the correct order, double check that. 1, 2, 4, 1, -1, -3. And this is a great way to check any of the problems you have that you're doing by hand that you might have to do by hand. My variables here are x, y, and z. And then we have the constants, which are 3, -4, and -18. So I'm going to put this in for A, this in for B, and we're going to solve that using the calculator. Okay, so now I'm going to do that, and then I am going to edit my matrix. So I have a 3 by 3, and I'm going to put in all the numbers. Really, the only reason why this video might take long is doing all this calculator stuff, because otherwise it's a pretty quick video. Or there's only 3 problems here. 2, -1, 3. Again, make sure all the numbers are correct. And -1. So double check. 1, 1, 2, 2, -1, 3, 4, 3. Yeah. Okay. And then we can do matrix B. This time it's, oh, I don't want to edit A again. That would be wrong. I want to edit B now. B is a 3 by 1. So it now is 3, -4, and -18. Now here's the beauty of this. Again, I just did A inverse B. You can type that all in again, or you could hit second enter, and look at that, it's back. Well, now it's going to use my new numbers, so when I hit enter, I get the values -2, 3, and 1. So what that means is XYZ equals 2, -3, -2, -3, and 1. Okay, yep. Oh, no, that's not a -3, that's a +3. Just wanted to double check that before I wrote that down. So we have, this is a +3. And so my final answer is -2, 3, and 1. And I'm done. So we have that one done now. And finally, we can do the last one. You guys try to set this up on your own. Pause the video, come up with your equation. We've done ones like this before. Theater sold 400 tickets. There's adult, student, and senior. So I'm going to just call that XYZ. Adult will be X, students will be Y, seniors will be Z. Now, we know X plus Y plus Z has to equal 400. That's the first one. You always do one where it adds up to the amount. Second, we do a cost one. The adult tickets cost $8, so 8X plus 6Y for the student tickets plus 5Z for the senior tickets. And we know the theater made $25.50. So that's our second equation. However, we need a third equation. And the third one says the number of adult tickets, which is X, is twice the number of senior tickets. Now, before you can put this into a matrix, you have to set this up, the third equation, up in the correct format. So you got to move the 2Z over. So this actually turns into X plus 0Y minus 2Z. I just subtracted 2Z over, equals 0. So that's the third piece that goes under here. Now I'm going to come up with my matrix equation. Here my A matrix will be 1, 8, and 1. My Y will be 1, 6, and 0. My Z will be 1, 5, and -2. I have my matrix of variables, X, Y, Z. And I have my constant matrix, which is 400, 2,550, and 0. This is going to be my A, my X, my B. So in your calculator, you have to do A inverse B. So again, we're going to just bring the calculator up and type those in and edit them. And like I said, this is the only part that's going to take just a little bit. 1, 1, 1. And like I said, you guys should be able to do this at this point, but try it on your own. You don't have to listen to the end of this if you don't want to. But like I said, it's important to practice these because it is the easiest way, I believe, to find your answers. And even though it looks easy, you still have to practice it so you don't forget what your steps are. And 0. And again, my calculator is already set up to calculate this, so I'm going to hit second enter to just bring up the same thing. Again, you can go through the whole menu and do that. I hit enter, and I get 100, 250, and 50. So my X matrix XYZ is equal to 100, 250, and 50. So what that means is that the theater sold 100 adult tickets. I can't spell. 250, those were students. Man, I really can't spell. Students. And then finally 50 seniors. And these are all the tickets. Okay, and that is it. That is how you use inverse matrices to solve systems of equations. Again, you guys are going to be mad now that you know how to do that and you had to do all the other ones, but you still need to know how to do all the other methods for the quiz, so make sure you practice what you need to do for each one. Alright, and we are done.